Intriguing inverses. Can you find the inverse of this shape? I'm going to actually ask you not to read the directions real quick. Okay? How do you think we would find the inverse of this shape? Find the values of all the points and switch them? A good set of points? What do you mean by that? What certain points? You want to pick out certain points? So my question is, what certain points? So you want to pick out important points. So you want to pick out points where the graph maybe changes direction? Like a vertex or something? Okay. So where is, in your opinion, an important point? 1, 2, 3, 4, 5. Negative 5, 0. Is that an important point? Then I'm going to put it in my table. 1, 2, 3, 1, 2, 3, 4. Negative 3, 4. Negative 3, 4. Negative 1, 0. Zero, 1, 2, 3, 4, 5. 0, 5 would be a good one. And then what'd you say? Negative 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Very good. Okay. So now what? How do you find an inverse? Switch the x and y. So I'm going to recopy my table, except I'm going to switch the x's and the y's. So 0, negative 5. 4, negative 3. 0, negative 1. 5, 0. And 5, negative 6. Correct? Thank you. So 0, negative 5, so 1, 2, 3, 4, 5. 4, negative 3. 1, 2, 3, 4, 1, 2, 3. 0, negative 1. 5, 0. And 5, negative 6. So when I do this, I have to do one of two things. I either have to, or I either should have written these in this order so I could connect them as I go, or what? I have to be really careful when I connect them, right? Because I could do this. I could here, 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 right? But that wouldn't look anything like the one that's already there. Okay? So when I wrote them down, I actually wrote these three down first, right? So I know these first three are going to connect. The first three that I drew actually went this way, right? Right? And then this last one, 0, 5. 0, 5 is this one. So that will connect here. And then this will connect here. Because I just need the same shape, right? Just reflected. Where is it reflected? Can I draw that in? When I draw it in, why do I draw it dotted? Yeah, is it really there? No, it just gives us some information, right? Gives us the behavior of the graph. So, are we good? Is this orange function the inverse of the original function? So, is the inverse also a function? No. The inverse is not a function. How did I know to write it in the sentence? Why or why not, right? Okay, good. So why or why not? X values are repeated. Very good. The X values are repeated. Questions? You're going to do 4 later. Actually 4 and 5 if you want to get technical. Okay? I want you to put a star beside this, the parabola. I want you to put a star beside this one, which is called exponential. I want you to turn the paper over, and I want you to put a star by this one, which is called logarithmic. And I want you to put a star beside this one, which is called absolute value. Those are the 4 I want you to do on this page. Okay? So what are you going to do here on this problem? Just like we did on the front, right? You're going to find points on this graph, put it in the table for the parent function. Recopy the table except switch the x and the y, then plot the new table, which will be the inverse, and then compare their characteristics. Compare the characteristics of the parent function and its inverse. Okay? Any questions about that? Okay. Yes, just those 4. Only the 4 that we put stars beside. Look at the other page, please. Inverses of lines again. You told me earlier that you can find the inverse of a table really easy. Do you still agree with that? And how do you find the inverse of a table? Switch x and y. Okay? You told me that you could find the inverse of a graph really easy. Do you still agree with that? And how would you do that? You would switch x and y, right? So what happens if I give you an equation? Would that be easy? How would you do it? Guess what? You will switch x and y. Anybody see a pattern going on here? Okay? So it says, consider this equation. Y equals 1/2 x plus 3. Okay? There's some stuff we could do here if we wanted to. We don't. Okay? We could get this table from our calculator. I'm not worried about that. You guys got that skill down. Okay? In the original function, imagine switching x and y. In fact, we're not even going to imagine it. We're going to do it. Okay? And even in fact, they've already done it for us. If I switched x and y, do you agree that the new equation would be x equals 1/2 y plus 3? Then let's solve back again for y. How do I get the y by itself? Subtract 3 from both sides. Everybody okay with that? So I have x minus 3 equals 1/2 y. Okay, I'm glad you said divide by 1/2. Okay, I'm glad you said that. Because normally when there's a multiplier of y, I would divide it to get it away from it, right? Do we divide by fractions though? Ever? No. What do we do instead? That's an equivalent operation. Multiply by its reciprocal. Okay? And what is a reciprocal again? You flip the fraction over. You don't flip the fraction off, you flip the fraction over. There's a difference. There's a difference. Okay? So if I flip this fraction over, if I find the reciprocal, it's 2/1. So if I multiply this side by 2/1, I have to multiply this whole side by 2/1. I don't know why you can't see that anymore. That doesn't make any sense to me. You can see it if I bend the paper, which is odd. What happens if I multiply this whole side by 2/1? 2x minus 6 equals what? Because. Okay? So here's the equation. Here is the inverse. How do you know it's the inverse? How do we find it? Okay, oh, I'm so glad you said that because we have to fix that. Okay, is this the inverse because the y is on the other side? If that's true, then this should be the inverse because the y is on the other side. Is that what we mean? No. How did we get this equation right down here? We started here and we switched the x and the y and then solved for the y. So if you're looking at just a table, how do you find the inverse? Switch x and y, right? If you're looking at just a graph, how do you find the inverse? Switch x and y. If you're looking at an equation, how do you find the inverse? Switch x and y. Anybody see a pattern? 2 people. Excellent. Okay. So let's graph the original function. We're skipping 4. Okay? Graph the original function. Y equals 1/2 x plus 3. What is the y-intercept? 3. Up on the y-axis, 3. What is the slope? 1/2. Rise 1, run 2. Rise 1, run 2. Or fall 1, run backwards 2, right? That still works? Now, that didn't really take me a long time to put all those dots on the paper, did it? The answer is no, it didn't. Okay? So how do I graph this other line right here? The 2x plus or minus 6 equals y. What's the y-intercept? -6. 1, 2, 3, 4, 5, 6. Where's my orange? What's my slope? 2. Rise 2. Run 1. Where should my graphs cross? Where should they cross? Physically, where should they cross? I'm not asking so much for a specific location this time, but for a general location for any graph and its inverse. On the line y equals x. Look at that. Ignore my crooked line and actually look at the fact that it crosses on the line y equals x. Can you see that? And what would happen if I folded my paper along the line y equals x and held it up to the light? This would lie right on top of this. That would lie right on top of that, wouldn't it? Okay? So you're going to answer 6 and 7. What do you notice about the graphs? Well, we just talked about that, so figure out a way to put that down. And then number 7, how are inverse relations connected to the inverse operations used to solve an equation? This is a very much of a higher level thinking skill. So make sure you take some time on that. Look at the back, please. How are you going to do this problem? Here's the original function. How do you find the inverse? I'm sorry, how do you find an inverse? Switch x and y. Have I ingrained that into your brain enough yet? Okay, let me try one more time. How do you find an inverse? Switch x and y. Excellent. Okay, so I'm going to switch x and y. I'm not going to do this whole problem for you. I'm just going to start it. So I'm going to get y equals 2x minus 4. I even said it backwards and wrote it correctly. That's so strange. X equals 2y minus 4. And then what do I do to solve for y? What do you do first? Add 4 to both sides. And then what do? Divide what by 2? That whole side, right? So if I add 4 here and add 4 here, I get x plus 4 equals 2y. Then divide everything by 2. What's x divided by 2? 1/2 x. What's 4 divided by 2? 2. What's 2y divided by 2? Y. Just to make sure that we're clear, you realize that these are the same thing, right? And this is not an inverse because y is on the right side. Everybody okay with that? So, use your calculator if you wish to get this table from the original function. Use your calculator if you wish to get the table for the inverse function, and then graph both. So you're going to finish this one, and you're going to do this one. Are there any questions?